I'm going to show you how to use Stapplet to calculate the margin of error and confidence interval lower and upper bounds. In a later video, I am also going to do this using Google Sheets. So in this process, I'm going to actually skip straight to the answer using Stapplet, and then I'll kind of take steps to go back and fill in some of this information here. With Stapplet, I'm going to use one quantitative variable single group, and I have two options. I'm either going to enter raw data or a mean and standard deviation, and I'll show you both of those. So with raw data, you're going to have a sample in a table, and I have my summary statistics here to come back to. So this is a sample of 25 observations. For confidence intervals, we need to either have a normal population or a large sample size. Now in this example, I have a normal population. Your sample should also not have outliers that can skew your data and not be representative of the population. And then there's also this note about not selecting more than 5% of the population. My population, like I said, it's normally distributed. I kind of designed it that way, and I have 1,500 observations, so taking a sample of 25 is just fine. Pasting my data in and beginning the analysis, it starts with a dot plot. I'll want to change that to a box plot and check and make sure there are no outliers. That looks pretty good. It's a little skewed, but it should be a fair representation of the population. You can see I have 25 observations. There's my mean and standard deviation there, which I also have outputted in Google Sheets. So the way that I calculate upper and lower bounds for a confidence interval is under inference. I'm trying to infer the population mean from this sample. So I want to do a one sample t interval for mu. If you want to know more about t, I did that in an earlier video. Lastly, I'll input my confidence level and perform inference. This is going to output the lower and upper bounds of my confidence interval. So I have 9 point, and let's just round that to 9 point. Actually, I'll leave all the accuracy. 9.714 is my lower bound. And then my upper bound is 13.662. So what we would say is with 95% confidence, the population mean is between the lower bound of 9.714 and so you kind of split this out, the lower bound of 9.714 and upper bound of 13.662. So that's how you can kind of say it as a sentence, as a kind of an inequality. We're sandwiching mu, which is the population mean, between those two values. And we can kind of look at that another way. We can also look at that as our point estimate, x bar. So you see point estimate here, plus or minus a margin of error. Now the way that this was spit out, I don't have that margin of error. So I would have to kind of figure that out. And the way to do that is, first of all, note that your sample mean should be right in the middle of those two values, halfway between, because we're sort of looking at a bell curve that extends outward. My recommendation is just go back to your Stapplet and look at that mean. So this is 11.688 on this one. And now if we subtract from either end, we should get the same number, and that's our margin of error. So 13.662 minus 11.688, and I'll just do this side by side so you can see what I'm looking at there. So let's look at the distance to the upper bound. That's 1.974. That's going to be our margin of error, E. And then I should get the same number subtracting the other way. So going from the bottom end to the sample mean or the point estimate, 9.714 minus 11.688 is a distance of negative. So I either want to go above by point of 1.974, that will get me to the 13.662, or I'll want to go from the point estimate down or negative that same amount. And so Stapplet kind of skips over all these steps, and it just gives us our upper and lower bounds. But I did want to show you that you can kind of reverse engineer this margin of error. And margin of error is going to represent what we think is the maximum amount of sampling error possible, as long as we only need a 95% of our outcomes to be included. Or another way you could interpret that is if we were to repeat this process and collect 100 samples, 95 of them would likely have a margin of error sufficient enough. We might have as many as 5 on average out of 100, or 5% that do not. So that's the way to do it with raw data. The other method is actually a little simpler. If you go all the way back and just use mean and standard deviation, you can type those in. So for example, 11.69, 4.78. Those were the sample mean and standard deviation with 25 measurements. And I would just do this same inference process down here, and I could get those same results. Now, if you wanted to do more than that, if you wanted to find, for example, a critical value and things like that, I would recommend using the video that I created for finding those t-distribution critical values.